My time is 6.5 seconds, and I'm looking for my displacement, right? Or I'm going to start identifying it as y. So what equation do we want to use? We need an equation that has initial velocity, acceleration, time, and displacement, right? That's going to be our second equation here. And we actually are being isolated for what we already need, so there's no rearranging. I'm going to put g for my gravity because it's a specific type of acceleration. So my equation, you've seen it before, x is equal to 1/2 at squared. Specifically for this problem and for the next few weeks, your displacement in the vertical is identified as y. Your acceleration due to gravity, acceleration is identified as g, like this. So it's the same equation, we just are using specific values now. And we can plug in our numbers. So 1/2 negative 9.8 times 6.5 squared. All right, I have a displacement of negative 207 meters. So this is my displacement, right? But the question asks for how high is the cliff, right? The cliff is 207 meters tall, right? That's how high the cliff is here. All right, let's try number 3, getting past the 10-minute mark on the video. So let me see if I can do this fairly quickly. A ball is thrown straight up and it rises to a maximum height of 24 meters above its launch position. So if I'm starting at ground level and I throw my ball up, when it's at its highest point, this here, my y, is equal to 24 meters. What is the initial velocity that the ball was thrown? How long will the ball be in the air? So we're looking for my initial velocity, right? It's got to be something other than 0 because I threw it up, right? It has some initial speed on it. My acceleration due to gravity is going to be negative 9.8 meters per second squared. My displacement is going to be 24. It's positive 24 because I'm going upwards, right? I'm gaining displacement in the upwards direction. And one trick you need to know based on what I said previously in the video, when my ball is at its highest position, the velocity is going to be equal to 0 meters per second. So in this case, when I'm at my highest point, my velocity is going to be 0 meters per second. Right? This is not the final of when it falls back down, but this is what the word problem is describing, the motion on the way up. So the motion on the way up ends at the highest point, and so I can identify my final velocity as 0. It asks for the initial velocity. I have initial velocity, acceleration, displacement, and final velocity. Using my equations, I'm going to pick this one because it has final velocity, initial acceleration, and displacement in it. Right, or you can say AX, that's perfectly fine. We are looking for our initial velocity, so I need to rearrange this thing. I'm going to subtract 2 acceleration displacement from both sides. So I got my final velocity squared minus 2gy is equal to my initial velocity squared. I noticed some folks were not taking the square root here. Once you are done with this equation, make sure that you do that. I'm going to do it at the end. So my final velocity is 0. So I can cross that up. Negative from my equation, 2 times negative 9.8, which is my acceleration, times my displacement, gives me my initial velocity squared. 2 times 9.8 times 24 gives me 470 is equal to my initial velocity squared. We got to square root this because the question is asking for the initial velocity, not the initial velocity squared. My initial velocity is positive. This negative and this negative in the equation cancel out, giving me a positive value for my initial velocity. And then the question also asks for how long the ball was in the air, how much time. So in this case, it's asking for the total flight time. There's two ways you can solve this. Now that we have our initial velocity, there's a number of equations that you can use to solve your time. I'm going to show you two different ways you can do it. So when you just use the flight up, we can find the time just for the flight, the time it takes to go up, and then double it because the time it takes to go up is equal to the time it takes to go down. So if we find the time it takes to go up, right, our total time is going to be twice that. So using our equations, you can pick any one you want. I'll use the first one because it is the easiest to manipulate. So when I rearrange for time, I'm going to subtract VI from both sides, then I'm going to divide by acceleration to get time by itself. So my final velocity is 0 minus my initial velocity of 21.7 divided by my acceleration, which is negative 9.8. Right, the negative 21.7 and the negative 9.8 will give me a positive time. We do not want to have a negative time. Time is a scalar. It is always positive, 2.2 seconds for the way up. Right, it took 2.2 seconds to go up. Right, my total flight time is my way up plus my way down. So my way down is going to be another 2.2. So the total time is going to be 4.4 seconds. The other way you could do this is with the same equation. So you would need to recognize that my final velocity is going to be negative my original velocity. So I've got negative 21.7 minus my original velocity. So this velocity is the velocity when after it has fallen back down to its original height. Right, it's position 0. So this will be our actual final once it reaches back down to our ground. The initial will always be 21.7, and our acceleration will always be negative 9.8. So, negative 21.7 minus 21. Gives me a total time of 4.4 seconds. All right, so we're looking at a 17-minute video. I'm going to end there. Please try the rest. Let me know if you have any questions. If you get stuck on one, just send me a message.